Okay, now let's talk about the overall significance of the model. This part is very easy and straightforward. And as I said in the introduction of this class, most of the time we overwhelmingly reject this test because this is a test of we call it the overall significance of the model. Okay, so again, the processes are exactly the same. The steps are exactly the same. Come up with the unrestricted model and restricted model. So in the unrestricted model, we have everything. We have beta 1, beta 2, beta 3, up to beta k. In the restricted model, we drop everything. However, guys, we need to keep a constant in the model, right? Because I think we have talked about it. If there's no constant in the model, it's not guaranteed that the expected value of the errors are equal to 0. So we need to have a constant in the model. So unrestricted model, restricted model, and it's very straightforward that what are we testing here? We are testing if all the coefficients collectively are equal to 0. Against what? If one of them is not equal to 0. And what is the interpretation? The null hypothesis states that the explanatory variables are not useful at all. So if you fail to reject this null, then you really don't know what you're doing in this regression, right? Because everything that you put in the model, collectively, they're not significant. So, and again, 99.999% of the time, we can reject this null very easily. Okay, so let's construct the F statistic. Again, there's nothing new here. Sum of square of the restricted minus unrestricted divided by the degree of freedom, which is the number of restrictions, and then divided by SSR unrestricted divided by its degree of freedom. Okay. So if you remember, we had an R-squared version of this formula, right? So let me remind you of the R-squared version of the formula. In a couple of slides before, we look at and you're expected to prove that thing at home. So it was equal to R squared of the unrestricted minus R squared of the restricted divided by Q, the whole thing divided by 1 minus R squared unrestricted divided by n minus k minus 1. Okay, so this is the R squared version. And intuitively, it makes sense. If you go back to the Venn diagram things, you know what are we doing. Either compare the R squared of the restricted and unrestricted, or compare the SSR, sum of square of residuals, for the restricted versus unrestricted model. Okay, so if I start with this equation, for the overall significance, I can simplify it even more. I can simplify it to this equation. So where's this equation coming from? The R squared that you're seeing in these equations, these are the R squared of the unrestricted model, right? So imagine this is my unrestricted model of x1, x2, x3, unrestricted, and this is the restricted model. This is y. For restricted model, there is no explanatory variable, right? So R squared of the unrestricted model is what? This is R squared of the model. The overall R squared that we see in the output of the R, right? What is R squared of the restricted model? What do you think? 0. There's no explanatory variable out there, right? So we can go ahead and simplify this thing very easily. So R squared of the restricted model is 0. R squared of the unrestricted model is equal to R squared. So the only difference is that how come this Q is equal to K? Think about it. Q is the number of restrictions. How many restrictions do I have? 1, 2, up to K. So Q is going to be equal to K. So this is how we derive the R squared version of the overall significance by using this formula. And again, regardless of what method you use, you come to the same conclusion, right? So the test of overall significance is reported in most regression packages. So the good news is that you will see this F number in the output of R. You don't need to do anything manually. However, I want you to learn how to come up with these numbers manually, because it involves some intuition. So that's why whenever it has something to do with the intuition, I want you to be on top of that. Do you remember that that equation for the variance of beta hat j? Even though it's reported, I want you to learn that equation. The same story here. Even though this F is reported in the output table, I want you to be aware of the relationship between F, SSR, and R squared. Okay. The null hypothesis is, again, usually overwhelmingly rejected. How we do it in R? Okay, so we don't need to, for overall significance, we don't need to do anything in R. We just run the regression. Remember, this is our regression unrestricted model, for the unrestricted model, the full model. And then look at the F statistic. This is F statistic that we're talking about. So it is already reported, and there are some number of stars on top of it. Look at that. There's 3 stars here. It means that it is significant at 1%. And again, 99.9% of the time, when you look at this number at the very bottom of the table, it's going to be a huge number, like 100, 50, 60, sometimes even greater than that. But you will definitely see 3 stars here. What does it imply? It implies that all these variables collectively are important. You should not drop them all. Okay, it makes sense. So this is the completely automatic. Maybe this one is the semi-automatic, so you have to, you can do it, you can treat it as the joint significance, right? Remember, this is overall significance. Now let's think of it as joint significance. So if it is joint significance, what did we do? You come up with, so step number 1, you wrote down your regression, right? Regression of the unrestricted model. Step number 2, you came up with your null hypothesis. Step number 3, you use that linear hypothesis function in R. Okay, I already have constructed my regression. I call it reg underscore UR. So here, so this is my maybe step number 1. Here is my number 2. The hypothesis, I'm saying that all of them, look at that, 1, 2, 3, 4, 5. All of them are equal to 0. Here's a little technical thing that I want you to be aware of. Look at that. For this one, for x3, I have x3 is equal to 0. For x2 and x1, I didn't write equal to 0. If you just leave the name of the variable, by default, R is going to assume that it's equal to 0. So it really doesn't matter if I write something like this, years, or write like this, years equal to 0. R is going to treat them the same. It's going to assume that it's not equal to is equal to 0, right? So usually people are going to leave it like this unless you want to test it against some specific number. So you want to test that, for example, one of them is equal to 1 or not. So if that's the case, you do, okay, C, then maybe x1 is equal, whatever the name is, right, is equal to 1. And then x2 and x3 and x8. So we're going to look at an example down the road, but this is how you should do it in R. And if I look at the output, look at that. Not surprisingly, this number must be the same as this number. Okay. And what else? So we're not surprised at all that there are 2 ways to do overall significance. So usually you just look at the very last row of a table, or you can use this linear hypothesis test. Either way, you get the same number. I want you to confirm this. So this is a very important exercise. I want you to give it a try and confirm this, that this is equal to this. So you have everything. You have SSR, sum score of the restricted model. What is it? For the restricted model, it's going to be 492. What is SSR for the unrestricted model? And what is R squared? R squared of the model is this. This is the R squared of the model. What is K? 1, 2, 3, 4, 5, 5. Right, so 4 is 5. I want you to go ahead and plug in these numbers and confirm for me that you get the same, you get to the same value, 117.06. This is important. Okay. So your job is to be able to read the table, interpret all these numbers, and be able to connect the dots between the outputs of this linear hypothesis function and the table on the left, right? I'm going to give you some sample questions for the exam when we get closer to the midterm too. But for example, I can leave this, I don't know, R squared blank, you're expected to calculate that. I can leave this F stat blank, you're expected to calculate that. But just make sure that you're on top of these equations. And given the fact that your exam is open book, you don't need to memorize anything. Okay, so this was the overall significance of the model. Okay, the last one that we're going to explore as a general version of the linear combination of parameters, right? So let's do that in the final video.